Okay, in this video, we are going to do some vector addition and then find the magnitude of a vector. And so there's a couple of things that we need to understand. I represents, and maybe I'll type this out because I'm better at typing. So I represents, maybe I'm not better at typing, the horizontal components. And I'll tell you in a minute what that means. And J represents the vertical components. And magnitude is total distance. And so hopefully that'll help us out here in just a second. So not even attacking this problem, um, I is going to be how far in the horizontal direction did we go? So I is going to be how far in the horizontal direction did we go? J is going to be how far in the vertical direction did we go? And then the magnitude of that is going to be just doing the Pythagorean theorem. And there are a couple of cool notations here. So these are all vectors. And so V is really written like that. It's a vector. So the vector V is I plus J, meaning that we're going to go one in the I direction. So one and then one. That would be our vector V. Our vector V is one in the horizontal direction, one in the vertical direction. And then there is our magnitude. Okay. Vector W, so vector W, again, we'd write that with a vector symbol, would be 3 in the negative horizontal, so 3. So we've got this piece of the vector. And then the J component would be -2, so it would be down like that. And the actual vector in question would be here. This would be our vector W. So that's a little bit about vectors. And if you know I and J, you could very easily find the magnitude. And the notation for magnitude is a double line. So the magnitude of the vector V would be double line with a V inside of it. It's like a double absolute value. And the magnitude of the vector V would be the square root from Pythagorean theorem 1 squared plus 1 squared, I and J. I and J. So the magnitude of vector V is going to be the square root of I squared plus J squared. Okay, this is what we call a scalar. A scalar means take your entire vector V and multiply it by 3. So that is a scalar. So let's go ahead and do that. Let's take our vector v. So we have vector v equals I plus j. And I want to apply the scalar of 3. So I want 3v, which means I'm going to have 3I plus j, which means that my vector 3v is going to be 3I plus 3j. That's not so bad. And ultimately, what we want to do is we're going to want to add 3v plus 3w. And so 3w, well, here's my w vector. And so my w vector is -3I minus 2j. I'm going to multiply everything by 3. And so 3w is -9I minus 6j. Okay? So now if I want to add this and add this, if I want to add those two together, I would add my I components and I would add my J components. So I'd have 3V plus 3W is going to equal the I components. 3I negative 9I is going to be negative 6I. And then the J components are going to be 3J and negative 6J, so minus 3J. So the vector 3v plus 3w is going to result in this. It's going to result in being 6 this direction. So 6 this direction. And then 3 this direction. And to find the magnitude of that, we would want to find this distance here. That's the magnitude of those two vectors added together. And of course, we can use Pythagorean theorem. This is -6, this is 3, -6 squared plus -3 squared is going to give us the magnitude or whatever squared, right? So we've got 36 plus 9 equals 45. And then, of course, we have to take the square root of that. For space, I'll write over here. So the square root of 45 is the magnitude of V plus W, 3V plus 3W, my bad. And my computer is just being a little slow. 3V plus 3W. That's the magnitude of 3V plus 3W. And it tells you to round to two decimal places. And so when you plug that into your calculator, you're going to get 6.71. So that's our magnitude, is 6.71.